We're going to look at air traffic control next. What can be done to improve capacity, to reduce noise through better management of the extremely crowded skies across the south of England? Can it make aviation a better neighbour for the people who live, who breathe, who work under the flight paths? Let's welcome Paul Haskins. Paul is General Manager of Business Transformation at NATS. Can you also tell me what that means?
Well, I've been in the post 6 weeks, so when I know, I'll let you know. But I've just moved across. I was the General Manager for London Terminal Control, so I was responsible for the airspace over the southeast of England and the controllers that look after the departing aircraft and also the final approach service we provide at the key London airports. And the presentation that I'm going to give today is to talk about what NATS has been doing and will continue to do to bridge the gap from today until we get the new runway, depending on the decision from the government later this year, and hopefully aircraft using it by ballpark 2025. Yesterday we heard from the Commission about the longer term and the capacity we need, but actually one of the things that the Commission acknowledged, and it was mentioned again this morning, is that the airspace, the invisible infrastructure that serves Heathrow in some respects we've been talking about, but it serves all the airports that have been referenced over the last 24 hours. That airspace is an invisible infrastructure and something that we shouldn't ignore, and the Davis Commission makes the point in its report, and hopefully I can bring that to light. We've got a few presentations. I must apologise to Mike. Halfway through his presentation, my soundtrack started playing. I don't know why, so I apologise that some of you heard some music while Mike was speaking.
I thought it was just in my head.
No, it was definitely. I was sitting there waiting for my slides to appear, so I thought you were about to steal all my thunder. So the picture behind me shows you 24 hours in UK's south of England, but in UK's airspace. Every one of those lines is an individual aircraft that we recorded in a 24-hour period, and we've colour-coded them to show you the various airports. And the airports are only as good as the airspace above. If we're going to have an efficient and safe operation, then we need to make sure that the bottlenecks that could accrue from not dealing with airspace modernisation are addressed to ensure that actually the airspace across the southeast of England is fit for purpose. And I could spend a few minutes trying to point out a very messy diagram. It looks like one of my children drew it with some crayons. But we've got a video, and we're going to play the video, and it basically builds this picture. And it's a live picture, 24-hour recording of our air traffic across the southeast of England. So let's have a look at that.
That's a fabulous graphic.
Thank you.
I really like that.
Much better than the presenter. Hopefully the video brings to life what's happening right now over the top of your head. And in some respects, while we've sat here over the last 24 hours, it's hard to believe that picture reproduces itself every 24 hours, 7 days a week, and so on. It's a very impressive, as you say, very impressive illustration of the invisible infrastructure that's the airspace. Now, you heard yesterday Martin Rolfe, the NATS CEO, set out the challenges that will face us all to accommodate an additional runway in the southeast of England and at Heathrow. But he also talked about the additional changes that we will need to make, innovative ways of thinking about how we sequence those aircraft and how we design the airspace. And I'm just going to use this opportunity to give you some examples of areas where we've already developed technology to face some of those challenges and other things that we will be doing in the future, as I say, to build that capability, that capacity, and ensure that we do it safely, safety being the heart of everything we do within air traffic control. The first one we're going to talk about is queue management. Then we'll go on to time-based spacing. So queue management, about how we get the aircraft, optimise those streams and get the aircraft into London, and specifically in this example for Heathrow. We'll then go on to time-based separation, which once the aircraft have arrived within the London area, how do we optimise their arrival sequence and ensure that even when the UK is suffering from windy, blustery conditions, we can maximise the landing rate. Back onto the ground in terms of airport capacity management and how, working in conjunction with all the various moving parts of the airport, we can ensure that we have the most efficient operation on the ground. And then lastly, I'll come on to talk about airspace and build on the comments that Martin Rolfe made yesterday. So again, rather than me trying to explain queue management, I have a presentation video, a couple of minutes, that hopefully brings to life what we mean by queue management. It has a code name, X-Man, for those of you who like code names, but the video will explain. So let's play the video.
Managing aircraft arriving into Heathrow has recently been introduced. This innovative cross-border arrival management system, also known as X-Man, helps cut the time aircraft circle in holding stacks, reducing the environmental impact of arriving aircraft and saving airspace users fuel and money. X-Man is a world-first implementation of the CESAR concept of extended arrivals management using multiple air navigation service providers, namely NATS Prestwick, the IAA Shannon, Eurocontrol Maastricht, and DSNA Brest and Reims. In the past, NATS controllers have only been able to influence an aircraft's approach once it enters UK airspace. That can be as little as 80 nautical miles from the airport, resulting in limited opportunity to manage the flow of traffic. The result? Stacks build up. The X-Man system works by transferring delay from the busy fuel-intensive holding stacks around the airport into the more fuel-efficient cruise phase of flight. When an aircraft is 85 minutes flying time from Heathrow, the arrival manager system begins to calculate any anticipated delay. Cross-border cooperation between neighbouring ANSPs means that air traffic controllers at Maastricht Control, Brest, Reims, Prestwick and Shannon are then able to slow down aircraft up to 350 nautical miles from Heathrow. System-wide information management, or SWIM, ensures the relevant information is shared directly with partner ANSPs. By reducing the speed of the aircraft whilst they are in the cruise, time otherwise spent in the hold is absorbed en route. Demand is better matched to capacity, all without impacting the overall duration of the flight. Following a successful trial period, the system is now being readied for permanent operational deployment. On a daily basis, controllers at partner ANSPs now start slowing aircraft down during their en route phase, when an arriving aircraft is forecast to spend more than 7 minutes in the holding stack at Heathrow. Since April 2014, NATS has recorded reductions in holding times of up to a minute for those flights influenced by the trial, saving airlines approximately £1 million in fuel and 5,000 tonnes of CO2, as well as reducing noise for communities underneath the stacks. X-Man will undergo further development in the coming years. Aircraft arriving from multiple directions will be merged into an optimised stream, matching arrival demand to runway capacity, further reducing the need for stack holding around the airport. The future of X-Man promises even greater savings for our customers.
Queue management, the queue management strategy program, with a particular focus on Heathrow, is one of the initiatives that NAS has introduced to try and reduce and ultimately eliminate holding for Heathrow, but other congested airports that have holding as a regular feature. At the moment, average holding at Heathrow ranges, but it sits at around about 8 to 9 minutes. So to eliminate that, it's quite a considerable challenge. And it's interesting, when I was watching the video in one of the rehearsals earlier last week, I thought, how do I make this sound really complicated? It sounds really simple. You just slow the aircraft down and they don't need to hold. Why haven't we done this 5-10 years ago? If you go back to that picture, the video that I played a few minutes ago, and that was just for the southeast of England, 3,500 flights a day, 25,000 flights flying through Europe. And what we're doing is we're manipulating and interacting with those aircraft quite a range outside UK airspace. And so all those moving parts of the European jigsaw puzzle have to be taken into consideration. If we slow an aircraft down in order to solve a problem at Heathrow, we have to make sure that we don't create another problem in one of our partners' airspace or in a different flow. And coordinating through those 25,000 aircraft a day is a very complicated mathematical puzzle to solve, but it's something that we have introduced, and as you saw on the slide, some of the savings we've initially seen from just the trial aircraft. Trial's been in since April 2014, over £1 million in terms of fuel costs. But some of the stats there in terms of the fuel and the CO2, but also the noise. And hopefully we plan to get to a stage where aircraft, we will still have published holds in the airspace network, but they'll be there for when things have gone wrong, not in a Hollywood sense, but if, for example, an aircraft has burst a tyre or there's a hydraulic leak on the runway, we lose a runway for a period of time. It might be thunderstorm activity. We see quite a lot of that across the southeast of England. We may still have holding for those unusual situations, but hopefully, as the video explained, we can move to a place where we've eliminated holding by having on-time arrival. And I think that's one of the challenges we face, again, as an industry, whether you are incentivised for an on-time departure. Obviously, the concept this works on is people arriving at the time that they're scheduled to organise that flow of traffic. And so sometimes actually leaving the aircraft on the gate a little bit longer at its departure airport may actually serve. And I think that's where, as an industry across the globe, not just Europe, that will be one of the challenges we faced about how do we ensure that we get the balance right. So that optimised the stream coming into London and specifically Heathrow. But one of the issues that we then face is that Heathrow, on a normal day, the air traffic controllers, being very skilled, land between 40 to 43 aircraft an hour. Now, the rate will change depending on large aircraft, smaller aircraft. You heard from the previous presentation, the vortex wake that's generated from aircraft requires an element of spacing. But what we also find is that when the wind blows at Heathrow, on average we have 80 to 90 days of strong winds at Heathrow in any given year, the landing rate will reduce. And the best way of describing it is a travelator at an airport. If you imagine that you're walking in the opposite direction to the travelator at the airport, if that travelator is moving very slowly, you'll cover the ground in a relatively short period of time. If we turn that travelator up, if we turn the headwind up, it's a windy day, and we ask you to walk at the same speed along that travelator, it will take you longer to get to the end of the travelator. Now imagine that travelator is the final approach pass at Heathrow. So in any given hour, it's taking a lot longer in terms of time for the same amount of aircraft to go down the final approach. And we see, on average, in a 35, 40 knot wind condition, sometimes the landing rate can be reduced down to about 32 aircraft an hour. So that's 8 aircraft an hour that are not landing. They're into the next hour. Then there's another 8 aircraft if the wind continues to blow. And the delays build up, and by lunchtime you sometimes see, certainly some of the carriers will cancel rotations into the afternoon because they have no way of recovering if they're losing 8 slots an hour every hour while the wind continues to blow. And so one of the things we've introduced is we've moved away from distance-based separation to time-based separation to try and counteract the effects of the wind. And again, I have a video that I'm going to play, and it will explain time-based separation, which went live in the spring of this year at Heathrow.
Heathrow is the world's busiest two-runway airport. ATC and pilots work together to maintain an efficient operation. But headwinds on final approach cause significant delays and increased airport holding. With fixed distance separation between aircraft on final approach, when the headwind component increases, the ground speed drops, resulting in a reduced landing rate.
The video has stopped. I did threaten one of my colleagues in the audience that he would have to come up and pretend to do this with his arms out if the video didn't work. So he's now beginning to panic in the audience. Can we have another go at playing that?
Heathrow is the world's busiest two-runway airport. ATC and pilots work together to maintain an efficient operation. But headwinds on final approach cause significant delays and increased airport holding. With fixed distance separation between aircraft on final approach, when the headwind component increases, the ground speed drops, resulting in a reduced landing rate.
Okay, never mind. I will continue to narrate the rest of the video. So as you can see there, the travelator, the idea that when the travelator's turned up, when the wind is beginning to blow, the amount of time it takes to pass down the final approach increases. And so one of the things that we have done through using 5 years worth of scientific research, we've been using LiDAR, which is a radar technology that allows us to measure the wake, the turbulence that the aircraft produce. So we've been using real data from aircraft on final approach to measure the effect that turbulence has in wind conditions. And you could argue that it's common sense that the windier it gets, surely that turbulence is blown away faster. But as I said, safety is in everything we do. And we wanted that scientific data before we went live and started operational trials. So we collected that data over a 5-year period, and in the end of March of this year, we went live at Heathrow. And one of the things, obviously, the wind changes second to second, minute to minute. And so one of the things around this tool is it takes live wind data from the aircraft on final approach. So it's receiving a live reading, it's receiving a reading from the aircraft, every single one that goes down the final approach, and it's organising the spacing. And it puts a marker on the radar because, again, from the air traffic controller's point of view, looking at the radar screen, they're separating aircraft by distance in terms of visually how they're looking at their radar, but they've now got to turn that into time. To give you an example, 2 aircraft, 2 jumbo jets, 5 mile separation on final approach in light winds. That's around about 135 seconds apart. The wind starts to blow, the travelator effect kicks in. Those aircraft are now coming over the fence about 165, 170 seconds apart. Still 5 miles apart, but obviously taking longer to cover the distance. What we've done is we've brought the consistent number, instead of the distance, it's now the time. And so we're back to those aircraft are still 135 seconds apart, but in this case, they're now about as that animation shows, 4.2 miles apart. So aircraft are physically closer together in distance, but in terms of if you were standing at the fence at Heathrow watching them land, they would still be coming over the fence in the same time period as if it was light wind conditions. So this isn't about more aircraft at Heathrow. This is about maintaining the schedules when the weather and other contributing factors try and reduce that landing rate. That's a world first at Heathrow, as I say, fully operational this spring. To give you an example, on the 30th of March, it was a 35-knot headwind on final approach, and bearing in mind this has only been in the system 4 days, the controllers were, although they're trained in the simulator, they'd done all the appropriate training and sign-offs, they were still very much getting used to this. We achieved a higher landing rate, and we think we reduced the delays by about half. And ultimately, we think that by the time that the system is fully bedded in, it will probably eliminate or go a very close way to eliminating the impact of strong winds at Heathrow and maintaining the schedule even when the British weather throws everything it's got at us. As it says there, it has the potential to adapt the system for other airports. It works best, for example, on runways that are just either serving just the arrivals. If you end up with a mixed mode runway, that's where you have departures and arrivals on the same runway, ultimately you end up with a bigger gap between your inbounds anyway, because you're fitting a departing aircraft into that gap. So you get less benefit, albeit you can still see that there is some, if you have a loading of inbounds, for example, you can see how the benefit could be found. So okay, that's got the aircraft on the ground. So the next thing we've been looking at is airport capacity management. And there's two aspects to that. One is we have been using data analytical skills and advanced simulations and working with key partners both in the IT world but also in the aviation sector to simulate the impact of decisions before we make them. So, for example, if you're running your airport and you're thinking of digging up a particular taxiway, it needs resurfacing, it needs new lighting, something like that, we can put in all the moving parts of that airport from the air traffic, the size of aircraft. Certain aircraft can only use certain width taxiways. Where will you create the bottlenecks, and which gates are going to be more restrictive? And actually you can identify when is the best time to close that taxiway, where's the best place to reroute your aircraft, might not necessarily be the obvious one, in order to get the maximum flow of aircraft around whatever you're doing on your airport. That's in terms of simulation, which means you can then go into that actual activity knowing everybody understands how it's going to be, the best way of optimizing the airport while that work's going on. The second thing, another example, is in the live environment, is in the TSAT, Target Startup Approval Times, where, again, previously you would have parked the tug and the ground crew on the front of the aircraft, and due to other factors going on the airport, or perhaps in the airspace that serves the airport, the tug driver and the crew sit there and have to wait. Meanwhile, there's an aircraft further down the pier wanting to go, doesn't have a tug, doesn't have the crew. And again, through the ACM, you can join all those moving parts together, so you can ensure that the aircraft pushes from the gate at the optimal time. It's not burning fuel on the taxiway, it's not congesting the taxiway. You can organise your departure sequence for the end of the runway by pushing the aircraft off the gates in the right sequence. You end up with a far more better passenger experience. I think we've all been on aircraft where we've arrived at the gate, you get on the plane, and then you sit there on the plane for 40 minutes. Now, by joining it all up, you get hopefully a streamlined machine that can deliver the passenger experience that we all set out every day to deliver. So that moves me on to airspace. And again, you heard from Martin Rolfe yesterday around the work that we have been doing and will continue to do to enhance our airspace and ensure it's efficient and modernised to meet the challenges of tomorrow. As I said earlier, it's the invisible infrastructure, and I can't stress that enough. The airspace can't be forgotten when we're talking about the additional runway and the output from the Davis Commission. It's something that goes hand in hand with developing the ground infrastructure. The ability of modern aircraft, you heard some from the presentation previously, but you heard some of the capability that those aircraft have. And if you look at navigation performance of aircraft, they can very much nail the line. Their GPS navigation allows them to navigate and fly routes. And that gives air traffic and the air traffic designers in terms of the airspace lots of opportunities. Previously, we designed airspace with old technology requirements in terms of aviation, aircraft technology requirements, and an airway, you had to have it 10 miles separated from the next airway, because the inaccuracy of aircraft navigation meant that the aircraft will be somewhere in that swathe, but can't guarantee it could fly the centre line. Modern aircraft can nail it within a few feet, and it allows us, in terms of air traffic, to design routes and put them much closer together. Now, that's not necessarily from a point of view of adding more capacity into the system, albeit that could be one of the benefits. But it also then allows us to choose, gives us options to choose where to put these flights. And we've talked earlier and yesterday around respite. And it gives us the opportunity to use the technology that both modern aircraft have, but future aircraft will develop, and make sure that we have an airspace system that works. Now, one of the things we do have to bear in mind, though, is that we, as an air traffic service provider, we provide that service to all users. So whilst some airlines and users have modernised their aircraft and have that capability, there are other airlines that are flying what I would call legacy equipment, old aircraft. We still have to accommodate those into the system. So there'll be a transition and a period of time, but we're able to modernise our airspace and get the most out of the precision navigation that modern aircraft give us. Now, that sounds like a lot like jam tomorrow, and we're going to design our airspace for the future, but we've actually already started, and we've broken our airspace modernisation programme, LAMP, we're calling it, the London Airspace Management Programme. We've broken it into various phases. Clearly, if you go back to the video I showed you at the beginning of the day, you wouldn't want to change that airspace, all the routes, the designs, in one go overnight. You'd be a very brave person. You'd hold your breath and hope the phone doesn't ring at just gone midnight when they flick the switch. So we're doing it in parts, we're doing it in phases so that we can manage it in both a sensible way for the end user, but also from the air traffic controllers, having to ensure that they move the amount of aircraft, 3,500 flights a day. We need to make sure we give them the appropriate training and support. And so we're doing this in phases. But the first phase, phase 1A, goes live early next year, February of next year, and it will affect London City and airspace out to the south and southeast of London. And I have an animation that shows you what the airspace will look like once we've brought it in. And one of the concepts that's part of that first phase is point merge. And it's how we get aircraft from the motorway network and stream them on the slip roads and onto final approach. And hopefully the video will play and you'll see what I mean. Before we play the video, sorry, apologies for this. Before we play the video, I think this is just acknowledging that, and it came out yesterday, and I think there were some people that attended the dinner that didn't necessarily have an invite to be there, where noise, impact, environment is going to have a huge part to play in those airspace designs, choosing where we put those aircraft, how we maximise the technology to give us the various options. And these are some of the social media examples. But I think it's really important, and you heard a commitment from the NAT CEO, and also Andrew Haynes talked about it from the regulator's point of view, to work with airports, with airlines, with the local community, to try and find that balance and ensure that we can move forward, we can design the airspace, but do it in a way that's collaborative, do it in a way where we're listening to everyone. Ultimately, those aircraft, if you go back to the video I showed, those aircraft have to be somewhere. It's interesting when people talk about, you know, will I get an aircraft over my house? And I think that video shows that already most people have aircraft over their homes. Different heights, different impacts, and we know that. And I think we're also becoming aware, previously the thinking was aircraft below 7,000 feet. We took into consideration noise impacts on the ground and visual impacts. Higher than 7,000 feet, I think the policy and the thinking very much reflected that actually the noise had dispersed by that. But we're seeing, certainly from some of the groups that represent the communities, and certainly from social media, that people actually feel affected and are affected at higher altitudes. And as such, we're going to have to work collaboratively. We've already, at NATS, we've shown several of the groups around Swanwick and tried to explain the airspace and what we do. And I know Sally's representing Gatwick in the background, she's waving. But Sally and some of her team came down to Swanwick, and we spent the afternoon plugging them in on the radar. We didn't let her have a go, but she plugged in, saw what the controller was doing, and trying to both understand the view of the local community, but also understand the challenges from air traffic, and see if we can start a dialogue to ensure that any decisions that we make are joined up and all the information is considered before we design the airspace and put aircraft in certain places. But let's see if we can get this video to work. It's not my day for technology, is it? You can see the concept, point merge. So we've got rid of the holding stacks for London City. We've moved the point merge, this arc system, out over the sea, and an aircraft fly precision routes straight into Heathrow. Into London City. What you would have also seen on that video is the departures. Because we've moved the arrivals further out, it allows us, both for London City and actually for Stansted and Luton departures, to take them out further to the east, get them higher a lot faster. And I think that's one of the things that we're looking to do with our airspace programme, is if we can eliminate the holding, if actually we can decongest some of the airspace. It means the departures, the modern aircraft that you've heard about, can climb faster, they can get away from the ground, less noise, they're more fuel efficient at the higher levels, so it's good for the environment as well as the noise, it's the fuel burn, and we can get those aircraft away. And when point merge comes in February of next year, you'll see some of those departure routes coming out of Stansted and London City, taking advantage of the things that I've just talked about. I think I'd close by saying that the airspace modernisation programme is happening. It's going to be needed for a new runway, but actually it's something that we're not waiting for the new runway. We're doing it now. We know that we have the aircraft capability to bring these changes in and show that improvement sooner rather than later. We can capitalise on modern aircraft and what they bring in terms of their part to play in the bigger picture. It'll ensure that we increase capacity, and hopefully from a flying public's point of view, you won't experience delays, certainly down to air traffic. At the moment, we're very proud of the record. 99.8% of aircraft in the UK do not pick up any ATC delay. You're very unlucky if you pick up any delay due to ATC in the UK. We want to maintain that, and we want to ensure that we modernise our systems and modernise our airspace such that you will continue 99.8% of the time to fly without any ATC delay down to UK air traffic control. So it's something we're proud of, and something we're wanting to maintain. But I'm just going to leave you with that, that picture as a reminder of what we're dealing with. That's 24 hours in the southeast of England, and we're very proud of how we turn that mess of lines into an organised air traffic picture. Some of the busiest airspace in the world. Gatwick, busiest single runway operation in the world. Heathrow, busiest dual runway operation in the world. And we're very proud that we make that work and continue to do so. Thank you.